Hello students, welcome to the classroom point. In today's session, we are going to discuss the hydration of alkenes. Watch this video till the end. If you like my explanation, then subscribe the channel and like and comment and share it to your friends. So first of all, what does it mean by hydration of alkenes? Addition of water to an alkene to form alcohol is called hydration of alkene. Now let us see how many types of hydration of alkenes are there. So types of hydration, there are three types of the hydration of the alkene, that is addition of the water to the alkene in the presence of the mineral acids like H2SO4, addition of water to the alkene in the presence of the mercuric acetate, and addition of the water to the alkene in the presence of the diborane. It may be BH3 or B2H6, both are same. When you add the water to the alkene in the presence of the mercuric acetate followed by the reaction with NaBH4, it is called the Oxymercuration-demercuration. And addition of the water to the alkene in the presence of the BH3 is called the Hydroboration-Oxydation. So to fully understand these particular concepts and the respective products, we need to see the mechanism of these three reactions. So let us discuss one by one. So let us take one particular alkene here. When you add H plus, means this is H plus is from the H2SO4. So H plus H2O. Then what happens here is this H plus ion initially attacks over this particular hydrogen, so that these pi electrons will be shifted over to this carbon in creating the secondary carbocation. But if this methyl group is being shifted here, then you will get the tertiary carbocation. So formation of the carbocation is the intermediate in the addition of the water to the alkene in the presence of the mineral acids. So whenever carbocations are formed, the reaction will continue till the formation of the stable carbocation. So the reaction will continue to rearrange. Now, this tertiary carbocation is formed. In this particular case, one important thing is hydrogen, what is added to this particular carbon is from the acid. Now, once the formation of the tertiary carbocation is over, now H2O molecule attacks over this particular positive charged carbon and gives this hydronium ion. Later, there is a loss of the H plus ion from this hydronium ion, so H plus ion is coming out. So this H plus ion is from the water, not from the acid. And finally, we get OH and hydrogen in two different carbon atoms of this alkene. So this is the molecule. In this particular case, here hydrogen is added, that we discussed already, from the H2SO4, and OH what is added from the water. Now, let us see the same reaction if it happens in the presence of the mercuric acetate. So when the reaction happens in the presence of the mercuric acetate, these pi electrons completely shifted over to the mercury and this pair of electrons will shifted over to the carbon and giving this transition state. The transition state name is cyclic mercurium ion. So this cyclic mercurium ion will be attacked by the H2O molecule. Pair of electrons are present in the oxygen atom, so it attacks over this carbon atom and opens this ring, so that H2O will be, hydronium ion will be formed here, and H plus ion from this particular oxygen will be removed by acetate ion, and this particular carbon and mercury ring, that means link, will be disconnected by the NaBH4. So NaBH4 will add hydrogen in this particular position. So finally we are getting the hydrogen to this CH2 carbon and OH to this CH carbon. So this OH is from water and this hydrogen is from NaBH4. And in this particular case, there is no formation of the carbocation, hence no rearrangement has taken place. But in this case, rearrangement taken place. And now, you see this particular in the presence of the diborane, BH3. I can write the BH3 as H and BH2. So, this H and BH2 will be added to this particular molecule in such a way that hydrogen will be connected to this particular CH. I will write like this. So hydrogen will go over here and BH2 part will go over here. So finally, hydrogen to this CH carbon and BH2 to this particular CH2 carbon. So it forms a transition state. This is the most stable transition state. You cannot add BH2 over here and hydrogen here. If you add BH2 over here, this particular carbon gets the partial positive charge, that is the primary carbocation like transition state, which is unstable. This is secondary carbocation like transition state, which is more stable. and afterwards this bond will be disconnected completely and this pi bond also will be disconnected completely. These two bonds will form completely. So that hydrogen is coming over here and BH2. And afterwards we are adding the hydrogen peroxide. So negative, this is monohydrogen peroxide ion. So this negative charge will attack over the BH2 boron and this sigma bond electrons will be shifted over to the oxygen and this bond will be broken and the negative charge will be given to the oxygen. And afterwards we get the molecule alcohol where hydrogen is added to the CH, that is this hydrogen is from the BH3 or B2H6. If you take the BD3, here you will get the deuterium and this OH is from the H2O2, not from the water. So generally in examinations they give the complete reaction. So to fully understand this reaction, you see the same reaction over here, so that at a single place we can understand this at a glance. I am taking the same molecule H2SO4 H2O. So I am giving these two molecules, this molecule. So here this OH is from the water, this hydrogen is from the H2SO4, this is from the H2O. This is a rearranged product. Interestingly, both of these products are the Markovnikovs products only. They follow the Markovnikovs rule, but the first one is the rearranged product. This is without rearrangement. So if you want to add water molecule to this double bonded carbon atom in the presence of the H2SO4, you don't get this molecule. You cannot add a hydrogen here and OH here in the presence of this H2SO4 and H2O, but you can do the same thing in the presence of the mercuric acetate. Okay. So in the case of the mercuric acetate, THF, NaBH4, OH minus, if you add here, so you will get the OH and hydrogen. Okay, hydrogen is from the NaBH4, that you must understand, because some reactions they give the NaBD4. If they use this deuterium, we have to add deuterium in this particular place. Now, if you don't want to get the secondary alcohol, but you want to get the primary alcohol, then these two reagents are of useless. Then you have to go for the diborane in the presence of the OH minus, H2O2, H2O. So in this particular case, whatever the OH is there, that is from the H2O2, not from both of these. Then the question arises, then what is the use of the OH minus here? It is very simple thing that you just see, this is the H2O2. When you add OH minus, it abstracts this hydrogen, leaves the negative charge over the peroxide ion, so that we get the O minus plus H2. So this is the attacking reagent. So from this, I think already here I had explained the mechanism. So OH minus is coming from the H2O2 and this hydrogen is from the BH3. If they use BD3, then here you have to add the deuterium. If they use D2O2, then you add the OD here. Okay. So hope you understand my explanation. If you understand, please like, share, comment this video. Thank you.